Okay, we are live. Hi, everybody. I'm Pierre from Be My App, and I'm here with TJ. Just before to start the webinar, I wanted to present a bit Be My App because we are doing webinars, but not only that. We are doing a lot of events for developers and startups. So if you want to learn cool things and attend cool hackathons and startup events, have a look on events.bmap.com, and you can register to the newsletter by clicking on the Join the Community button. TJ, today you're going to talk about NativeScript.
Yep.
Okay, you're okay? You're ready?
Yeah, I'm ready to go. Ready for me to share my screen?
Yeah, and just before to start also, feel free guys to ask your questions in the comments section, and we'll do a Q&A session at the end of the webinar.
Excellent. All right, are you seeing PowerPoint slides here? All right, I will go ahead and get started. So I'm TJ VanToll. I'm just going to talk to you a little bit today about NativeScript and Angular 2, sort of how Angular fits into the NativeScript story as well. I'm coming to you today from the United States, from the great state of Michigan. So it's around noon here, so sometime around the beginning of the day. And basically what I'm going to talk about is what NativeScript is. I'm going to show a quick little demo. I personally think the best way to sort of see a framework or get an idea of what it looks like is just to see a little app built in action. So that'll be most of our time today. But I do want to take a minute to just quickly tell you what NativeScript is and why you should really care, why you should bother listening to the next 40, 50 minutes or so. And then if we do have any questions that come in, we'll take whatever time is left for any outstanding questions, or we can always reach out and chat later if you have anything that you want to continue chatting about. Now, NativeScript. I think the best way to explain what NativeScript is to really describe where it came from, or why we thought the world needed yet another JavaScript framework. Now, the story really starts with a company called Telerik, which you may or may not have heard of. We're a software development company, really big, especially in the .NET space. And Telerik is where NativeScript got started, somewhere around 3 years ago. Telerik, we have since been acquired by Progress Software, so we fall under the Progress Software umbrella, so that's why you'll see this Progress branding all over the place, but same basic company, same basic idea. And at Telerik and now at Progress, we have a lot of experience in the hybrid development space. And what I mean by hybrid is Apache Cordova, PhoneGap, Ionic, all of these different frameworks that build on top of Cordova. And if you're familiar with this approach to app development, the idea is that you're really getting a best of both worlds scenario. That is, since you can write using web code with any of these frameworks, you're writing in things like HTML, CSS, JavaScript, using frameworks that you're already familiar with, and you get all of this code skill reuse that you normally wouldn't have if you're building, say, natively on Android or iOS. The idea with Cordova is that you also get this other side of the equation, this 100% native access as well, that you get the full access to device APIs, and you get this really rich experience with native feeling apps. And the idea is that with this architecture that you can really hit the best of both worlds as your solution. Now, at Telerik and now at Progress, as I said, we have a lot of experience in the space. We have what's known as the Telerik Platform, where we make a whole bunch of tooling with hybrid. We also have what's known as our Cordova Marketplace. You can go to plugins.telerik.com. Essentially, we have what I believe is the largest listing of Cordova plugins outside of the main Cordova plugin listing on their own website. And the reason we did this is with the Telerik Platform and with a lot of the other tooling that we have, what we kept hearing from our customers, from our users, is that people increasingly wanted to get this side of the equation, that they felt limited by hybrid in the fact that it's great that you can use this web, sort of your web skills, your DOM skills, but that it became increasingly difficult to get that native app that you really wanted at the end of the day, a really really well-polished iOS and Android solution. So if you look over our Cordova plugin marketplace, what you'll find is a lot of plugins that we built to sort of push the boundaries of what you could do with Cordova, or do with a web-based solution. So you'll see things like a native page transitions plugin for Cordova, several others. I encourage you to look through the list. We're really trying to push the boundaries. But at the end of the day, after sort of experimenting with this, we found that with Cordova, that you can only go so far. Cordova is at its heart web-based, and if you try to build too many plugins, it gets kind of hacky and messy, and it sort of gets away from the core idea of what Cordova is built off of. So NativeScript started with that premise with some early prototypes a few years ago. We've launched NativeScript for the first time last year in March, I believe, sometime last year, and we've been building our community up since then. Now, what NativeScript actually is first and foremost, it's an open source project. So you can go to github.com/NativeScript. You can see everything we do is up and available there. It's Apache 2 licensed, so it's very liberally licensed, so you can do what you want with the framework. With NativeScript, we're trying to let you build truly native mobile apps. And I use that word truly because we are not, sort of unlike Cordova, we are not using a web view. We are not using HTML. We are not using the DOM. We are building native iOS and Android user components, native interfaces, apps that feel native and feel like they belong on the device. But we still wanted to give you that skill reuse. So you can use things like JavaScript, TypeScript. You can optionally use Angular, which we'll be looking at today. And we use a subset of CSS for styling your native apps. So that's briefly what NativeScript is. But since nowadays there's a ton of frameworks out there that you can use to build apps and sort of get to iOS and Android, I thought I'd just very quickly, before we actually dive into the code of NativeScript, just give you 5 quick reasons that you should care about NativeScript at all, and sort of what I feel differentiates NativeScript from other frameworks that are out there. The first is really performance. With NativeScript, as I mentioned with some of the backstory, that we really wanted to provide a no-compromise solution. We didn't want to run into some of the restrictions we hit with Cordova. We wanted to give people the ability to just build the native apps that you'd expect to have on iOS and Android. And since I think seeing this sort of on your device in your hands is more important than seeing a few animated GIFs here, if you look, if you just get out your iOS or Android phone right now and search for examples NativeScript in the app stores, you can multitask while watching this and just sort of get a sense of what NativeScript feels like on your device, so you can see the performance for yourself. You can also, if you just Google NativeScript showcases, you'll find our showcases page that has a couple dozen apps that our community and some of our customers have built as well, if you want to see some things that weren't built by us. So first is straight up performance. The second is code and skill reuse. So in addition to give you that performance, we still wanted you to give you essentially as much skill reuse as you possibly could. And so this means with NativeScript, you're writing your code in JavaScript or optionally TypeScript, but it also means things like using CSS to actually style native Android and iOS user interface components. It means using utility libraries based off of NPM. Most of our architecture is built on top of NPM. Our plugins are distributed through NPM, which we'll look at in a minute. But we also let you use native iOS and Android components as well. So if you're not familiar with iOS, their sort of rough equivalent of NPM is known as CocoaPods. It's just a library of, or I should say a collection of iOS libraries and SDKs you can use in your app. And we let you use those in NativeScript. We'll also let you use Android libraries from places like Android Arsenal and other places where you can get native libraries as well. So that's 2. 1, performance. 2 goes into code reuse. The other one is Angular and TypeScript support. Now with NativeScript, the NativeScript sort of core was built with TypeScript from day one. We've always been pretty big fans of TypeScript, and we think it especially fits the mobile model when you're actually building native mobile apps quite well. So we've been using TypeScript for a while. Now the Angular support came later. We were actually, since we used TypeScript, and when Angular made their announcement that they were switching to Angular, which I think happened about a year and a half ago, we were pretty interested in that. And we've been working with Google for the last, I think, year and a half now to actually make NativeScript plus Angular a possibility. Now, for those of you that aren't as familiar with sort of Angular's architecture, Angular 1 shipped with an architecture that was very much tied or coupled to the browser and to the DOM, meaning that when you use Angular 1, your solution really can't live outside of the browser. There are specific DOM APIs that are encoded directly into Angular. And so using Angular 1 in something like NativeScript is just impossible. But with Angular 2, we've been working with the Google team to take any of those APIs that are specific to the browser and abstract them out into sort of like a parent API, these platform-specific APIs. And the way that works is then the Angular team can implement, say, the browser platform and encode all of the specific DOM things they need to do to, say, like manage a tree of UI components. But then us in NativeScript, we can actually implement those same high-level APIs with Android and iOS code so that you can code once at a higher level with your UI components and have the ability to render both for Android and iOS, the web. And we'll take a look. We'll be diving into code here in just a second, and we'll actually see what that looks like in practice. Now, number 4 of 5, and the thing that actually puts the native in NativeScript is really our defining feature, is that we give you complete access to the entirety of Android and iOS. Now, if you look at this code here, I'll give you a minute because this can take a while to wrap your head around what's happening here. Now, the first thing to note is that this code here is valid NativeScript code, and you'll see that this is also valid JavaScript and it's also valid TypeScript syntax. So these are semantics you're probably familiar with if you've done any sort of web development before. However, if you were to take this code and say like paste it into the Chrome DevTools or try to run it in a browser, even though the browser would recognize the semantics, it wouldn't know what this API is because this is actually an iOS API, UI alert view that's used to create essentially the web equivalent of an alert. So what we do is that we actually inject the entirety of iOS and Android into the JavaScript VM that runs NativeScript apps. And it's not just iOS, it's Android as well. So you can do things like allocate native objects, really anything that's possible in the native ecosystem, we make possible in NativeScript as well. Now, I'm not going to go into full details of the sort of architecture here and really dive into how NativeScript works. If you're curious, you can just Google how NativeScript works. I've also got a bit.ly link down here that you can use that really dives into sort of how we actually make this possible, how we're able to inject these APIs into JavaScript, and also the trickier part of how we actually make this bridge so that when this code runs, we actually are instantiating a native object under the hood. But the important thing for today is to sort of get the high-level picture is that the reason we did this goes back to why we sort of broke away from Cordova or didn't want to go with that architecture. We didn't want to limit what was possible in your app. We always wanted to give you access that if something was possible on iOS and Android, we wanted to let you have the ability to do that. Now, that being said, we also realized that the reason that a lot of developers, especially a lot of web developers, choose to use a framework like NativeScript is very specifically for the reason that they don't want to write code like what you see on the screen here. So it's sort of this weird dichotomy in that we did want to give people access to this, but we also realized that this should be an advanced usage scenario. If you have a very specific thing that you need to, but for common things, what we do in NativeScript is that we take these platform-specific APIs. So this example is, suppose you want to allocate a file as part of your mobile app. It's a relatively common thing that you need to do. Now, with the NativeScript runtime, you can do things like what you see on the bottom of the screen here. So on Android, you could type out new java.io.file and run that code. For iOS, you could use this sort of verbose monstrosity API that you see on the bottom of the screen here, which will also allocate a file at time for iOS. But what we do for NativeScript is that we abstract for common tasks, we abstract these APIs into JavaScript and TypeScript modules that abstract these details away for you. So instead of writing this mess, you would instead just import our file API from our file system module and then just allocate a file that way. The cool thing is, though, these APIs that we write are implemented using what you see on the bottom of the screen here. Meaning that when you actually need to debug or sort of extend or build upon something that we do in NativeScript, the source code is very approachable. It's just a bunch of TypeScript code. You're not diving into a different language or dealing with some weird semantics and bytecode that you're not familiar with. you're staying in TypeScript, where you may or may not be already fairly familiar with how that language works. The same mechanism also applies for the UI as well. So much like you type new file to allocate a file and we take care of the platform-specific mess, you can do the same sort of thing with UI components as well. And this also works when Angular comes into the picture as well, which we'll look at in a moment. Now, if you're curious about these modules, what sort of abstractions we have, as I mentioned, all of this is open source. These modules are part of the main NativeScript repo. So it's github.com/NativeScript/NativeScript. If you sort of want to peruse around as you're looking to this, the UI folder has a lot of goodies in there too, so you can look around. Our NativeScript plugins also build upon what's possible that you don't see currently in this list, and we'll look at NativeScript plugins here in a minute. So that was 4 or 5. I got one more reason you might want to use NativeScript, and then we'll actually move on to the demo, which is my favorite part of this. And the last point is something that I kind of mentioned already, but that NativeScript is a fairly major engineering effort by a major software company. So I feel the need to mention this because in today's sort of crazy JavaScript world where framework can sort of come and go every day, you should know that Progress is a major company. I think we're almost, I don't think we're quite 2,000 people, but we're a fairly large global company. The NativeScript core team is something like 24 people, and there's a bunch of other people that are involved in NativeScript in some sort of supplementary role as well through things like sales, marketing, and that sort of thing. This lots of times leads to the question of, okay, if Progress is making this and it's free and open source, then how does the company actually make money off of the product? And so I'll show you a few quick things for that. So we have what's known as UI for NativeScript. So we sell premium UI components. So if you're building a NativeScript app and you need some really rich charts, you need pie charts, line charts. There's a few other components in here as well. We will sell those to you. We also have enterprise support. So if you work for a larger company, often these big companies want some sort of support backing so they know that they'll have some help when sort of things go wrong. And we also have what's known as the Telerik Platform, which is some premium tooling and things that you can use, sort of a backend as a service, analytics, some other things that you can add to your NativeScript app as well. Now, I won't really be talking about any of these premium things today. Really, everything in NativeScript is truly completely free and open source. You don't have to pay us anything to go out to the app stores or anything like that. So everything I'll be showing is completely free, open source, part of that distribution. So with that out of the way, I don't know, are there any existing questions that have come in since we started here? Otherwise, I'm going to go ahead and move over to the demo. I'll go ahead and get that ready. Say I don't see any in the comments right now. If any others come in, I'll go ahead and tackle them. Else, I'm just going to go ahead and keep going here. So I'm actually going to then build up a small NativeScript app from scratch here, just to give you an idea of what actually using NativeScript feels like. Let me clear this up here. The first thing to know about NativeScript is that you actually interact, you build and work with your NativeScript app from a command line interface, which is what I have open here. I've got open my terminal on my Mac. NativeScript also works just fine on Linux and Windows. You also work from the command line there. Just one small note on Linux and Windows, because you're actually building native apps, you're unable to build iOS apps on those platforms just because you need to have a Mac in order to build and compile. We're using Xcode under the hood on iOS. So you can build Android on Windows and Linux, but you'll need to have a Mac in order to develop for iOS. Now, the NativeScript command line interface is built on top of NPM. So I would NPM install NativeScript to actually install the CLI. Once I've done that, I'll have a NativeScript command and also the shorthand TNS command, which is just short for Telerik NativeScript and is a little shorthand that makes dealing with your applications just a little bit easier. You use the TNS create command to actually scaffold out an app. So if I wanted to build a quick hello world app, I could do that here. But for the purposes of our talk today, and I'm just grabbing my code over here, I've already scaffolded out a little app that'll save us a little bit of time so we can get straight to the point of what building a NativeScript app actually feels like. So this little sample app is called Groceries, and I've got a couple of things that I'll be adding into this app as we go. At a high level, this is the folder structure of a NativeScript app. the couple things I want you to pay attention to is, first of all, you'll note the package.json and node modules folder. Now, if you've built with NPM before, if you've worked with Node.js before, if you've just sort of consumed NPM libraries as part of some front-end project, you're probably familiar with these conventions. But with NativeScript, we try to embrace sort of existing Node and NPM infrastructure and workflows as much as possible. So you can see that really all of your configuration of your app is just in your package.json file. You manage your dependencies in this file as well. The core of NativeScript, the NativeScript modules that we looked at earlier, come from here. I've got a few NativeScript plugins that I'll show in a minute that I'm bringing in as well. And you can see most of my dependencies here are actually Angular. And I'll also mention quickly that we're not altering Angular in any way. Specifically, Angular, for the most part, just plays in quite nicely. The magic that sort of integrates NativeScript with Angular happens as part of this NativeScript Angular plugin that you see here. But the key thing to know is that really you're building on top of semantics that you already know if you've done Node before, or at the very least, you're using reusable skills. So the things that you learn as part of sort of managing your dependencies and such in NativeScript, you can reapply to things like Node or utility management in any of your front-end applications. Now, the other two folders to pay note to are app and platforms. Now, what platforms has is your actual Android and iOS sort of native apps. So if you've built for native Android before, you might recognize things like your Gradle file and some of your configuration files that live in here. For iOS, you'll notice things like your Xcode project and all the little various utilities and such that you need to build an iOS app. And this is where they live in NativeScript. But the cool thing is that with NativeScript, we really treat these things as generated code for the most part. You can see that I'm actually ignoring these platforms from source control altogether and just generating them as I need them. Instead, I'm doing most of my work in the app folder, which is sort of the crux of where your application is. And if you're familiar with Angular 2 at all, you can know that it sort of follows Angular 2's model as well of where your source code lives. Now, at a high level, what the NativeScript CLI is actually going to do when it builds your app is it's going to create a native app, an Android or iOS native app. And then it'll take your code from your app folder and inject it into the appropriate spots in the platforms folder, which is cool for a couple different reasons. But I'll show you an app just to give you an idea. Now, before we got started today, I scaffolded out a super simple. I actually ran this app. I can show you from the command line. You use the tns run command to actually build and deploy your app. So I ran this thing both for iOS to get this emulator up here, and I also got it going for Android. So I've got these both chilling out here. And let me move these over a little bit so we can see them a little bit side by side. Now, one of the things that I guess the main reason this architecture where app changes get sort of sent into the platforms folder is that when you actually want to change your app, so let me bring up the code that actually builds this. So this is an Angular 2 application, so don't worry too much about the Angular 2 syntax here. I won't talk about Angular too much during this talk just because I think there's probably better places to learn Angular 2. I'm instead going to focus how Angular 2 sort of fits into the NativeScript story. But this is sort of it literally is your hello world of Angular, where you're actually building a component that just has a simple label that's outputting this hello world change here. And what I'm going to do is I'm going to use the live sync command that NativeScript ships with that is actually going to set up a little watcher with this watch flag that's going to watch for changes that I make to my app folder. You can see I haven't made changes yet. And when it detects this change, it'll actually save this code. In this case, it's TypeScript code. So it'll also compile this TypeScript file into JavaScript code and then transfer that code, or live sync it, if you will, into the platforms folder so that your actual native app updates, making your development workflow pretty fast. So let me go ahead and update this. I'll get a little more excited about NativeScript. Pretty excited already. This will take a second just because it takes a little while for the CLI to first get the watcher up and running, because it's going to watch for TypeScript code as well. And we'll see. This should take just a second. I think it synced once with the initial change. Let me me get a little more excited because I think it picked up on the first change I made when I updated the file. And it should sync here in a second so we can see this change. iOS and Android will be racing here. Yep, and so there's Android with the exclamation parts, and normally iOS follows a second or so behind, and there's the change there as well. Now, I think why this is cool is remember here that the comparison is building with native iOS and native Android applications, which normally to actually update iOS and Android apps that you have to go through a full build cycle because you're dealing with actual bytecode. But with NativeScript, we're building native UI components, and I'll get into what this actually means here in a second. You're building native UI components, but you're doing so with what feels like a very web-like workflow, where you make your changes, and the changes just go ahead and update in your emulators pretty quickly. It usually takes about a second or two to actually update, both for iOS and Android. Now, in terms of the user interface, I've just got a label here. Let me paste in something that is slightly more complex here. Just give me a second. And we'll paste this in just so we can see a little more complex of an example. And let me move this over so we have a little more screen real estate to deal with here. Now, if you've worked with Angular 2 before, most of this code is actually going to look fairly familiar to you in terms of how we build user interfaces with Angular 2. The big difference is obviously in this template. On the web, you would type something like button, sign in, rather than this button that you see here. Now, the reason we take this sort of approach in NativeScript is what we're doing is each of these UI components you see in your template, so stack, layout, text field, button, we're actually implementing these APIs with native code. So what you see here, both on Android and iOS, these aren't, there's no web view. These aren't DOM components that you're seeing here. You're seeing a UI button and an Android.widget.button on the screen. And if we go into that modules code that I talked about earlier, which is somewhere down here, UI button, if we looked at the iOS implementation for a minute, you can get an idea of just roughly how this works. So when this button actually gets instantiated based off this Angular template, what's going to happen is that we're actually instantiating a UI button under the hood. This is the code that's actually going to run and generate what you're seeing over here. The cool thing about NativeScript is that's really completely transparent to you. You just type button, and you just let NativeScript take care of how this actually renders out on iOS and Android as well. So that's UI components. I want to get a little bit further into this. So my first example was the UI, but of course, this app looks pretty ugly. This is not particularly interesting. So I'm going to show very briefly here how you actually style your NativeScript apps. So I'm going to add two things in here. The first is I added an app.css file, and I added some CSS rules that we'll talk about here in a minute. And then I also added some style URLs to my component. Angular 2 supports styling your app both at really like a global level and then also at a component level, and just showing very quickly how that can work. So these are rules that apply to my entire application essentially, and then these are rules that in these files that apply just to this little login component that I have here. Now, if you look at this actual CSS file here, you'll see that semantically, again, this should look fairly familiar. This is CSS in the sense that you use selectors, you use brackets, you define actual rules as name-value pairs in your file. So this should look pretty familiar if you've worked with CSS before. Now, some things might look unfamiliar, the UI components that we use, but language-wise, things should be fairly similar. So you can use element selectors to actually select the tag names that you see in your components. You can use CSS class names, you can use IDs, you can use descendant selectors, all these other type things that you may know from CSS. Now, the one big difference is in how these actually work. Remember how I said earlier that there is no browser here. So there is no this isn't like the equivalent of going into the Chrome DevTools and saying, oh, the background color is white here. There's actually a native component that's controlling this page. So again, what we're doing here is that what NativeScript does is parse this CSS file. using some just existing open source CSS parsers. And for each of these rules, we take these and actually apply the native equivalent of each of these things. So there's a native equivalent of how you apply background color to a UI component on iOS, and the same in Android. And that's really where the heavy lifting is happening on the NativeScript side of things. Now, what that also means is that this isn't a complete CSS implementation that you see here. So even though you can do things like background color and font size, certain CSS rules just aren't possible to replicate in native iOS and Android. And some of them just sort of present some major performance issues, or that it's not really a good idea to make certain, especially layout things, possible from CSS and replicate those in native iOS and Android. So instead, if you looked at this template, and I can show it again here real quick, it was login.html, you'll see things like stack layout and grid layout and special layout tags that we have that lets you lay out your UI components that you have in your app, but do so in a way that A, we can actually make work on iOS and Android, and B, work in a performant manner so that you're not actually getting slowed down by some heavy math that's going on our end. So that is CSS. We got a couple more things. I'm going to add a few more things to this app just so we can get it to the point that it's somewhat fully functional. So the next thing I'm going to add here, let's go ahead and toss in one more version of this app, is I'm going to actually add some logic to this. I'm going to make the user able to log into this application. And at the moment, I'm just sort of hard coding in that if this works, just toss up a little alert so that you can see things work. And we'll come over here so that you can see this happen. But the reason I show this example is the way I have this app architected is that I've created this shared folder. And what shared in this context means is that I've written this code in this area of the application in a way that's not specific to my user interface at all. For instance, this login service is in user, and there's this login function here, and I'm actually using this to authenticate, hit my backend with a little post. This is just some generic Angular 2 code. But because this actually it's sort of UI agnostic, there's nothing that says update this user interface or anything like that, I'm able to use this service in my native app. So I can use it on Android, I can use it on iOS. I should see an alert over here. But it also means that this same code is something that I can directly use as part of my web apps as well. And actually, if I look at this application, this is the, let me fix the screen here. This is the web version of my groceries app. And what I'm actually doing in this web implementation is I'm using this exact code you see here completely verbatim as part of my web app. Now, again, to go back to what we said earlier, the reason this is possible is that in the native app, or I should say in the web app, Angular is actually implementing this HTTP API, and they're doing it with web API. So you'll see something like XML HTTP request and all the various APIs that go into making that possible. So what we did with NativeScript is we re-implemented the entire XML HTTP API, and I think it's XHR. We implemented this in the entire interface of it, but did so with Android and iOS native code instead. So what that means to you, though, again, as an end user of Angular 2 and of NativeScript, is that you can code to the Angular 2 APIs, in this case, the HTTP API, and get code at the end of the day that works both in your native apps, so native iOS and Android apps, but also in your web apps as well, which I think is pretty cool. So with that out of the way, let's back out of this. I want to got about 10 more minutes here that we're going to chat about NativeScript. Let me find my mouse again. And the next thing, so we've went over how to build UI components, how to make them look halfway decent with our CSS implementation, how to build some back-end logic. The next thing to chat about is actually how to do routing. And let me paste in one more example so we can see how this actually works. And we'll switch over to Android here. Now, what I changed here is I just made the this login call, when it comes back, instead of alerting some nonsense, I'm now actually navigating to another page. And again, this is just Angular 2. This is how Angular 2 works. But the one thing that's different is if I go to where I'm actually declaring my router here, I think it's this app routes here. Yep. Let me get this out of the way. Now, especially when we get into this sort of code sharing idea where you can share code between web and native apps, routing is a little bit of a unique beast in that routing just tends to work differently on Android and iOS. On native, you have things like a hardware back button. On iOS, you can do the like swipe to go back gesture. And those things really don't exist on the web. But at the same time, on the web, you have things like a URL. You have a refresh button, a back button. You have a hash that can appear in the URL. Things that there are really no direct equivalent of in the native world. So what we've chosen to do for our implementation is that we again let you code to the same Angular APIs. So we're not really changing Angular's APIs altogether. But instead, we provide this little extension. You can see that normally if you're building an Angular 2 web app, you'd router method from Angular router. And what we've done is we've just wrapped that call so that by coding to our actual APIs, you can use the same basic approach with Angular 2, but let us take care of the sort of heavy lifting when it comes to how to make routing work on Android and iOS. So in this case, I'm just routing simply between a login page, and I've got a little like grocery management. This is code that is again being used essentially verbatim, other than this one little change where I have to essentially tell NativeScript that I need a little bit of help making the router work between native and web apps. But pretty cool to be able to use Angular for this as well, because again, it's important to think, just to take a step back, that you are building truly native apps here. This is a completely native Android app. We also have a completely native iOS app. And normally to get to this point where you have a functional login screen where you're using a bunch of these native UI components, you're normally building two completely separate code bases, one with iOS, Swift, or Objective-C, another with Android or Java. So it is pretty powerful to be able to code to one API and get to both of these ecosystems at the same time. With that in mind, I've got two final examples here, and then we'll start to wrap up. Because even though I've talked a bit about code sharing, I've showed a little bit of how you can share code between web and native apps, and I do think that's pretty cool. I think it's important to note that if you're going to go through the hassle of building a native app, because building a native app isn't really easy, no matter what technology you really use, if you're going to do it, you should really take advantage of the fact that you're building for native. I mean, native devices are capable of a whole lot of things. I mean, if you just look at this app, I've added a few little things like you have a native sharing widget. Sharing is just built into your native app. You have pull to refresh. So if I go over, I've got it hooked up into this app. If I need, let's see, what other fruit do I have? I could use some limes. So if I add an item to my list on the web, pull to refresh can be a little bit of a pain to implement on the web. On native, it's really just a quick switch on the native controls. It's something that's really quite easy to implement. I could also make, depending on my use case, I could make this an endless scroll list. I could add some like swipe actions. There's all sorts of things I can do that, since I'm using native, I guess the potential is so much higher. And so with that in mind, I'm going to add two last things to this application. The first thing I'm going to do is I'm going to go back to my app.css file. And one thing that we added in one of our recent releases was support for CSS animations. So again, you can see that this code, and I think I might have to, I'm not sure if I have to turn that code on or not. You can see that the syntax feels exactly like CSS web animations, where you're defining an animation name and you've got keyframes going here and other things as well. So it feels fairly familiar, but remember that you're dealing with native applications here. So what is, I guess, what is possible, or what the device is capable of, is just significantly higher, because you're not dealing with the DOM. You're animating completely native iOS and Android user interface controls. And what I'll be doing, I just had to restart my Syncer because I broke it, is that I'm going to be taking a background image. We'll see a background image appear in the back here, and I'm just going to scale it. You can see I'm switching from a really scaled in view, and I'm going to back it out and switch to a really zoomed in view, which will add a nice little effect to this login screen. And you can see that it'll feel pretty polished and hopefully should work here on Android and iOS. I think it's syncing. Yep, so you can see it on Android, start to build in that change here, and then you'll see it on iOS happen here as well. But again, I showed this just to show you can push the boundaries. And a background, sort of a background change isn't exactly groundbreaking. So to hopefully iron there, put that point, what's the phrase I'm looking for, to really hammer that point home, I think that's the saying I'm supposed to use. One of our NativeScript community members wrote this explosion plugin, which first of all, pretty awesome name, and also very descriptive name, because the plugin does exactly what you would think it would do, and that it makes things explode. So what I'm going to do is I'm going to take this login screen here. Currently, it is just logging people in, which is kind of boring. So instead, I'm going to have it queue up a series of explosions and make some of these things on the screen actually blow up. Now, I'd like to show this just to remind you that we are dealing with bytecode here. You're not dealing with the web. So what you build with this sort of solution, the bar is just so much higher in terms of what you can do. So what I'm going to do is I'm going to make some things blow up. You'll see this will blow up. This blows up as well. And you'll see in a second the entire application will blow up, which, of course, there's no API you could really use to do this in the web. There's no equivalent of this sort of thing existing. And what's cool about NativeScript is that anything you've seen, like if you've seen an iOS or Android app that does something, you know that you can do that in NativeScript because you're dealing with native code and because all of the native APIs are available. And just to give you a sense of that, so let me back this out. So we're dealing with normal code in here. Like in this app, for instance, I'm doing a couple small little tweaks to the status bar because I wanted this to tweak the status bar to look a little bit differently. And I just have some really quick code in there to do that. I have some code in here to just sort of play with the colors of the hints. I pre-filled this, but if I back this out, I have some code to change the appearance of that because I didn't quite like it. All these small little tweaks. And through using NativeScript plugins, which is what some of these things, my pull to refresh was a plugin, explosion field was a plugin, you can really greatly expand upon the sort of native things that you can do. If we look at the explosion plugin in particular, sorry, I'm just bringing this up here because I screwed that up. You can see the real power in that this is the plugin in its entirety. And all it's doing is just using an existing Android library. It's just bringing in that library and calling its API. And that's really all this plugin needed to do to make things blow up on the screen. And if you're interested, show a couple other things here. If you want to get an idea of what plugins are out there, you can go to nativescript.rocks, and there's a little plugins link here. And you can get a sense of just how much, excuse me, do with NativeScript, the sort of things that you can build. You can see if you need an autocomplete, if you need different loaders, if you need to integrate with Azure, geolocation, all sorts of things that you can do. You can just, I guess I just showed this just to give you a sense of the scale of the number of existing solutions that are out there. You can also go to NPM. Remember, our plugin system is built on top of NPM, so you can just head here and search for NativeScript, and you'll find, I think we're over 300 things now. So NPM sort of a raw search. The NativeScript Rock site is a little more of a curated look at the plugins that are out there and available. And with that, that's most of I wanted to show today. If you're at all interested in this, this demo was pretty short. I just try to give you a brief idea of what you're dealing with NativeScript. Our website is nativescript.org. If you do want to check out NativeScript further, if you really want to dive in and learn the framework a little more, if you click this Getting Started link here, there's 2 buttons to tutorials that we have available for learning NativeScript, and it's really the best place to get started. If you do want to use NativeScript with TypeScript and Angular, as we were showing today, this tutorial is where you'd want to start. If Angular is not your thing, NativeScript as a library, we're fairly low level, so you can just use vanilla JavaScript as well, and we have lots of users that do that. So if that's something that sounds more appealing to you, go ahead and try out our JavaScript tutorial to get started. Finally, if you have other questions, so if you have any questions for me today, I'll take a minute here in a second and we'll answer any of those for you. But if you're seeing this later, you can always reach out to either me or NativeScript on Twitter. Our Twitter handle is, as you might expect, NativeScript, and we watch this account pretty closely. If you ask any questions there, we should be able to help you out. You can also join us on our community Slack channel. So if you just look for NativeScript community Slack, you should be able to find this. But our community Slack is fairly active. I hang out on there. Most of the core team members are on there periodically, and we try to help out the community. And we've got a pretty active group there. It's a great place when you're getting started with NativeScript to ask questions, sort of bounce ideas off people to see where to go. And with that, I think that's all I have. I guess I'll thank you again for having me. Are there any other questions that came in? I think that was the end of my slide deck.
Okay, thank you, TJ. So yes, if you have any questions, please use the comments section on the YouTube page to ask it. I'm gonna let you a few seconds to do it. During this, I wanted to tell you guys that we are always searching for people who could be interested in talking about any topic during a webinar. So if you guys feel comfortable with any kind of technology and you think that could be relevant for a webinar, feel free to send an email to Lou, L-O-U @bmyapp.com, and she can arrange a webinar with you. Something else. So I talked to you before the webinar about what BMAP is doing. So feel free to have a look on events.bmap.com, and if you want to receive the newsletter, join the community. And tomorrow we're gonna have another webinar about Johnny 5. It's a JS framework allowing developers to make IoT stuff. So if you guys are interested in that also, it's going to be tomorrow at 6:30 European time, I guess. So let me refresh the page to see if there are some questions. Okay, TJ, there's no question for the moment, but feel free, even after the webinar, to post your questions, and TJ can respond to it later on.
Yep.
Okay.
Yep. On the YouTube channel, on Twitter, we're pretty active there, so feel free to reach out.
Okay. Thanks a lot, TJ, and see you soon.
Yeah, thanks for having me.
Bye.